Okay, guys, so we start off this video with 4 questions. So what type of energy represents the stored energy of an object? The movement or motion energy of an object is blank. The formula for finding kinetic energy, and we will do an example problem where we find kinetic energy, but obviously we need to know the formula, and Bernoulli's equation. What does that state? Okay, so those are some important things for this topic and this video. Okay, so first we're just going to go over a few concepts. The higher an object or person is above the ground, the more gravitational potential energy it has. Potential energy is the stored energy of an object. So a loaded spring would be a really common example of potential energy. Kinetic energy is the movement or motion energy of an object, right? And that was one of our questions. The movement energy, motion energy of an object, that's kinetic. Mass and speed determine kinetic energy. And we're going to go over a kinetic energy problem here in a minute. Electric energy is the energy created by electrons moving through an electrical conductor. Lightning or electricity are excellent examples of electrical energy. And then finally, chemical energy. Make sure we can see this. Chemical energy is the energy stored in the bonds of chemical compounds, which would be atoms and molecules. There are several examples, but a few: batteries, biomass, petroleum, natural gas, coal. Those are all examples of stored chemical energy. Okay, so then we go into our kinetic energy problem. Okay, let me get my marker ready. Looks good. Okay, so we got a 2 kilogram mass moving at speed of 5 meters per second has a kinetic energy of what? Okay, so we start off right where we need formula. K is for kinetic, as you probably could guess. Give me a sec to write this thing out. Equals 1/2 mv squared. Oh. So then we start plugging some stuff in here. Again, solving for K, we'll drop that 1/2 down. And the M, the mass, is 2, right? Because it was a 2 kilogram mass. And V for velocity is 5. Squared, right? Okay, and we can go 1/2 times 2 is just 1, right? The inverses of each other. And 5 squared is 25. Yes. Okay, and so then finally we drop it down. 1 times 25 is 25. And making sure we have the right measurement on it is this will be in joules, Joules. Okay, and there we go. That's our answer. The kinetic energy in the situation is 25 joules. Okay, and then 2 other things we want to talk about. Bernoulli's equation, that was one of our questions at the beginning. Bernoulli's equation states that the sum of the pressure, potential energy, and kinetic energy per unit of volume of an incompressible and non-viscous fluid in a steady flow at any point along the pipe remains constant, right? So that was a lot of stuff, and the key thing we wanted to hear was remains constant. Okay, and then finally we have a skier at the top of a mountain. So this is just, we're just throwing in like a really common question. The skier begins at an elevated position, thus possessing a large quantity of potential energy, right? As the skier begins the descent down the hill, potential energy is lost, and kinetic energy, right, meaning the energy of motion, is gained, right? And so that's an example of potential energy being the skier at the top of the hill and kinetic energy as they are skiing down the hill, an activity that involves motion. Okay, so with that, we get to the end of the kinetic and potential energy video. Might want to go back and look at these questions here real quick and make sure we're comfortable with those. And if we are, we're probably in good shape. And best way to practice like some of those kinetic energy type problems is just to get in the app and go to work and see if you can solve the problems.